Tonight's speaker is Dejan Miličić. He is a developer advocate for RavenDB focused on helping companies onboarding RavenDB development and supporting developers working with this second-generation NoSQL database. After more than 20 years of experience as a software developer and consultant, Dejan is still passionate about open source, professionalism, and supporting local software developer communities. With his share of battle scars, he is constantly seeking ways to prevent problems by promoting type-driven development, functional programming, RavenDB, and behavior-driven development. So welcome, Dejan. Take it away.
Thank you, and thanks for having me. Idea here is to have short theoretical introduction and then to have some also actual live coding and showcasing of this theory being applied in practice. So just briefly, I'm a developer, I'm a mathematician by education and developer by trade. I'm a proponent of software craftsmanship movement values. Currently, I work as a developer advocate for RavenDB. So this is interesting choice of career development. You can either go and be individual contributor for until retirement, or you can go and enter management. This is some kind of interesting mid path. So we'll see how that develops for me. So far, I like it very much. And I'm a big fan of functional programming. And as I'm growing older and more experienced, I'm thinking more and more that our industry is sometimes taking different turns in not too good directions. So I see functional programming and strongly typed programming languages as a good path. I'm also a big fan of RavenDB. I started using it for my own projects, discovered that this is a very, very good solution, and then I started using it in projects where I was working as a consultant. I'm mainly using Microsoft programming languages, C#, F#, but lately I've been starting playing with Idris. So if you are interested in functional programming languages and in development of something that will probably become household technology in like 30 to 50 years, take a look at the Idris. I would like to tell you about my journey to BDD because it's not the brightest one. And I will tell you what were my problems and how I managed to solve them. And today I'm using TDD and BDD, but path for arrival to that point was not easy for me. As I stated here, testing is like flossing. So we all know we should be doing it. We all experienced errors in production. I have my share of experience, and basically I've seen all kind of hard things, and I'm carrying my share of scars with me. So no one will tell you that testing is a bad thing. This is something, this statement that testing is a good thing. Testing will help you. Testing will help you uncover errors and mistakes you made before going to production. No one will dispute that. But unfortunately, when I look around me, still in 2021, you don't have too many developers doing it, or at least not enough developers, I think, should be using it. I started right after university. I started working in a company using Microsoft technologies, and I started with a classic ASP, which is in some way back now. And I essentially ended up being trapped within Microsoft monocultural ecosystem. So various developments in Java world, for example, were developing. Python was out, Ruby was out, various package management systems like GEMS were out. And at one moment, I realized I missed all these new things, new development, and I was kind of in a bubble of my own. And I went through all these web forms and MVCs and WPFs and .NET Core. And during that transition, I had a bit of awakening, starting to discovering other communities, discovering other developments, figuring out that I should be looking more outside the Microsoft ecosystem. Later on, luckily, some new winds starting blowing in Microsoft, so .NET Core emerged, MVC, testing was introduced as like legitimate way of development software. So luckily we catched up as developers using Microsoft technology started catching up all these technologies. And just to briefly remind you what TDD and BDD are all about. TDD is short for test-driven development. Idea here is to turn things around, not first develop code and then write tests for it, but the other way around. So you first write tests, and these tests are failing. So this step is called so-called red step, because your tests are failing and you see a red color as a mark of test failure. Then you go with that test and implement the actual code of your future application to make that test pass. But what is interesting and important here, a recommended approach is to write just a minimum amount of code to make this test pass. So nothing more. And then after your test passed, you go back and refactor code that you already written in that phase. And this cycle is intended to be very short. So you write very small tests, you go write minimum amount of code, and things should be unfolding very fast. So this is idea that you have almost dopamine reward every time that you see green color of the passing test. And idea behind TDD is that with this approach, you will be slowly building your software or application, and design will emerge as a result of writing all these tests and slowly advancing towards goal. And with TDD, it's even appropriate that first implementation of the first test could be you hard code value and return. So if you write test, okay, my method will return even number, for example. In this first implementation, you will hard code number 2. This is completely okay, but then later on, as you're writing new tests, they are failing, and then you are slowly building your code. And I stated event sourcing here. You may be wondering why. It's because proponents of TDD sometimes are very dogmatic. They're almost condemning people not using TDD as a methodology, and this is something we can or cannot like. But the thing is, there's no silver bullet in existence, especially in our profession. And the reason I stated event sourcing here is to address this typical criticism that we can hear. TDD proponents are claiming that basically design will emerge, and people who are opposing that are giving event sourcing as an example of the design that could never emerge as a result of applying TDD. So TDD is not a silver bullet. Sometimes you go to the industry that is using something like event sourcing. In my opinion, you should be moderate, you should be balanced, you should be using something like TDD, but you should also be having some kind of mental contemplation about the domain you're developing, and at least some basic planning of what you intend to do. TDD tests are basically composed of 3 phases. So you have a range phase where you set up environment, you see data, and you prepare conditions for the execution of your code. Then you have act phase where you actually run your system under test. testing and you execute method or whatever you want to do. And then a third phase is actually checking if the result of the execution or the outcome of the execution is expected one. I think we are all pretty much familiar with this. And I want to bring your attention to something very, very interesting. You remember I mentioned 3 phases, and I was speaking about red and green, and this is the usual cycle. So you go red and green, sometimes refactoring. But we neglecting this refactoring phase, not only during actual execution of the TDD practice, but what I want to say is that we neglect the refactoring and its meaning. So what happens if you refactor your code and this refactoring makes your test fail? This means that you change the implementation of your method and test failed because implementation changed. This is called brittle test. Brittle test is sensitive to the implementation details, and such tests are having the case of tight coupling with your implementation. And essentially, this is a problem. Not only problem that is resulting in tight coupling, you also have like sociological, if I may call them that way, problems. Meaning that you want to, as you developing your test, you want to have battery of the test, 100 or 500 or 5,000 of them, depending on the size of the project. So in practice, what will happen when your developers are doing refactoring or correcting some bugs? What you want to avoid is people commenting out tests which are failing because they are in the hurry. What you want to actually test in your application are not implementation details. You want to test behavior of your code. So if your code is performing some kind of calculation, you don't want to base your tests on the data structures being used. So if I switch from red, black tree to the B+3, I don't want my tests to fail, and they shouldn't be failing. So this is typical problems I'm seeing with TDD being applied in practice, that refactoring phase is often skipped for, I don't know, unknown reasons. Maybe this dopamine shot of a green passing test is a dangerous one. And then I also see people writing such tests which are too tightly coupled with the implementation. I stated here mock-assist versus class-assist, mock-assist versus class-assist, and this is also interesting discussion, not for this occasion, but essentially mock-assists are mocking calls to other methods, and they are just verifying if call to method succeeded, and class assist are actually executing calls between the methods. I personally like to use class assist approach because I'm, as you will see in the end, I'm essentially using integration tests when I'm developing my applications. BDD is the evolution of TDD, and it's addressing behavioral aspect of your testing. As I said here, what you want to test is not details of the implementation. You should test your behavior. And behavior is somewhere on the trace of that, but not only that. BDD emerged as a way of bringing together business people and developers, because that's what we usually do. We are not building, unfortunately, we're not building compilers, we're building business applications. And what we are doing, we are trying to talk to subject domain experts, write down scenarios, and then transform these scenarios into a set of acceptance criteria. So what you can see here is typical narrative, typical language, or shall I say domain-specific language of BDD. As a role, I want to use specific features so that I can benefit from it. You certainly remember the first article on BDD and this canonical example of ATM. So as a person with account in the bank, I want to use ATM to withdraw money, for example. And then based on this, as I want, so that narrative, you form acceptance criteria in the form of given initial context, when event or action happens, or when call to some method or service happens, then I have set of expected outcomes. And this specific language has been tested in practice and proven to be working well. So developers are thinking more about business scenarios, what we are trying to achieve, and we are thinking less from the technical perspective. And this is also where BDD as a methodology comes. We should concentrate on the language. For example, if you're building application, user is a technical term. You should actually distinguish what user is and what types of users you have. So the more we speak in business terms, the better software or better applications we're going to implement. And for this domain language of given, when, then as a series of action, we also started developing frameworks. Cucumber as most famous one, but you also heard about SpecFlow or Gherkin for .NET. So these are frameworks that are enabling developers to develop with BDD philosophy using domain-specific language. And I'm coming now to the part that I announced. So since TDD is not set of recipes, especially for people starting to use this paradigm or this process of development, I myself had set of very hard problems. Where should I begin? What I should be testing? What should be granularity of my test? Should my test cover one class or one method or a set of related methods which are calling each other? I was faced, and I was reading lots of articles and watching lots of conference talks. I also had problems with structuring of my tests. I had problems with this dilemma: should I be mocking calls or not? Should I be just mocking external calls, or should I be treating like everything as a distributed system? So whenever I cross the boundary of the process, should I mock this or not, and to what extent? And this precisely, these questions was something that was preventing me from actually using TDD in practice. And this is pretty bold claim that BDD is actually TDD done right. But I found this on the I found this exact phrase on the internet. So BDD and the specific approach that I'm going to demonstrate this evening was something that helped me finally using this methodology. I started writing behavioral tests, which are testing functionality, which are testing behavior, not the development. I started focusing more on a business level specification. And BDD is great because it is directing you to this so-called pit of success. So the system technical stack and whole approach should be guiding you through a whole project development process with the good outcomes. So BDD is stimulating you to use business level specifications. You write them down, and you have specification of what your users need, not what you think or assume they need. You talk to them, you get specific terms, you get business scenarios that or dynamics that they want to achieve. You write that down as a specification, and then you transform this specification into a set of executable methods. Once you implement this specification, you have working implementation that's been verified by the specification. And from that moment on, your specification is now becoming a set of regression tests. regression tests are tests that will prevent you in the future from introducing bugs or any kind of problems into existing implementations. So specification is executable. It will verify if your implementation is correct from the business perspective. And then after that, in the future, you have set of regression tests which are guarding you from introducing bugs. And this is very important. Why? Because if you want to refactor something which is important, you want to have automatic tests with you. Otherwise, you will be thinking, like most of developers working on legacy projects are thinking, this is important, this works, I better not touch it. With this approach, this philosophy is completely erased, and people are happy to go and refactor to improve code, knowing that they have safety net of tests. What is also interesting, if you're disciplined enough, every time you get a bug report, because you cannot produce software without bugs, every time someone reports bug to you, first action should be to write test, which is reproducing this bug, and this test will fail, which will be the act of test failing will be the verification of the bug you detected, and then you go and fix this bug. Once test passes, you know you fixed your bug. So over time, not only that you will have regression tests from the specification, but your bug reports will be transformed into additional tests, which only can make you feel better, and you actually are sure that if you made some kind of mistake, you will never make it again because you have test which is covering that. Also, specification, which is now acting as a regression test, is you can treat it as a live documentation, and it's never outdated. Why? Because these tests are conforming to business requirements, they are executable, and they are always updated. So essentially, idea with domain-specific language is to have humanly readable specification. So you are achieving this as a side effect, but very important side effect. And this was the theory. Now I would like to show you the code. But before I do that, do you have any comments or remarks regarding these two topics of TDD and BDD? Okay, as I usually say, when I deliver software and I hear nothing from the customer, and this means they are not using it. I hope this is not the case here. So what I'm going to present today is a very, very small toy project. And this is how I do my projects. This is not, I don't dare to say this is best practice. This is something that works for me. And this is also important, that you find something that works for you, produces good results, and that's it. Because if you're comfortable within your technology stack and set of tools you decided to use, you will use it with joy, and you will produce your results to the benefit both of you and people working with you and customers. What I also did not mention is when you have a set of BDD tests like this one, when you have a team working on it and you join new team members, onboarding becomes very, very easy because new developers will have BDD tests. They'll be able to read them, understand English language. Although this is executable, as you will see, we are using English language to describe business functionality there. So they are able to comprehend what have been done so far, and they are able to easily jump on board and start contributing. So this is aspect that I did not mention, but this is something that I experienced over years. So the toy project I'm going to use is based on my standard stack. I'm using CQRS approach, and I'm using Jimmy Bogart's mediator library to implement CQRS. CQRS is nothing fancy. It's usually associated with event sourcing, but you can use CQRS without event sourcing. With CQRS, you divide all interactions with your systems into read side and write side. So all your interactions with the system are either on the read side queries and on the write side commands. This pattern is rather old as a way of interacting with system. Idea here is that your queries will return the state of the system without altering it, and your commands will alter the state of the system without returning any result. Commands, of course, can return success or failure as a result, but for example, if you want to get the number of employees in your company, you will use query. This query will not or should not change any data in the database, for example. And if you're creating a new employee, you should call command for that, but this command will simply return success or failure to you, or some people will also allow for command to return ID of newly created object in the database or in your system. You will notice that in this list, I'm not mentioning Cucumber or SpecFlow or any other BDD framework, and yet I'm going to use BDD. And this is very interesting because I'm using XUnit, which is TDD framework for implementation of BDD tests. So I think this will be very interesting for you to see. I'm using Fluent Assertions library to verify results of the execution. I'm using Bogus library to produce some test data when seeding. And I'm using RavenDB test driver because RavenDB is my choice of the database. I'm using RavenDB test driver. What is interesting here is that a RavenDB test driver will enable me to run a RavenDB in memory. So as you will see, my tests will provision in-memory instance of a RavenDB database. They will be working with it. This database will be isolated from other tests, and after test completes, RavenDB instance will be disposed. So this is enabling me to run end-to-end tests or integration tests or whatever term you would like to call. In practice, over the years, my experience is that whenever you don't need to mock something, don't mock it. So when I'm testing things, I like to have actual components of the system instead of just mocking them. Of course, as I said, every time you cross the boundary of the process, you're essentially building a distributed system, and some of the components of this distributed system are under your control. So database, for example, with your test, even if you don't have in-memory version like RavenDB, you can use Docker to spin up a local database. But for example, if you're sending emails, then you simply want to treat this as a call that will be made to a component which is not under your control, because usually I'm going to use something like SendGrid or MailChimp, and these systems are not under my control. So for me, it's enough to verify that calls to these systems have been made with correct parameters. Okay, and this is my project. I hope it's not too tiny for you to see what is going on. If it is, please do say, and I can zoom it a bit more. So what I have here is very, very simple system, and the usual structure of my project is that I have a main project and additional project, which I'm calling specs. By the way, if someone knows how to turn this feature off with Visual Studio, when I click on the project, it's opening CS file, I would be grateful to hear that trick because it's very annoying. So I usually have spec project and I have my main project. I already set up infrastructure for unit tests, etc., not to waste your time on infrastructure. What I want to show you is the actual folder structure. So I have feature folders, I have subfolders with the names of areas in the product in the project, and then I have actual either commands or queries implemented within one file. So you remember I mentioned that my system of work is using CQRS. So what you can see here are two implementations. So let's say this is e-commerce system. So I have create product as a command, and I have a get product as a query. So create product will create new product in the database, and get will return products without altering database. In the spec folder, in the spec project, I have XUnit package, and here is a set of my BDD tests. So again, I'm mimicking the structure of the main application project, and I have again feature folder, which enables someone who arrives at the project to quickly and easily match and find where is what located. And as you can see, I have here products matching products again, and I have two folders for these two command for the command and query. I have a folder with matching names. Now you may ask yourself why I don't have classes here. This is because I'm doing following. I'm developing so-called scenarios. So one business scenario would be add new product to the database, for example, or to the system. So I'm using technical term here. Let me use more business-oriented term like system or even website. So you're speaking with a non-technical person. So this non-technical person will say to you, okay, I would like to have functionality for adding new product to my e-commerce website. And then from this static statement, you will turn this into the action, dynamic one, which will be, okay, this is scenario of adding new product to the system. And then within this scenario, I have different variants. I have something that I call happy path. So happy path is the execution path where everything is fine. I supply the name of the product. I supply the price. Database is working fine. I have authorization. I authenticated and I have authorization to add new product. So everything is fine. So this is happy path, execution under ideal condition. And this is what I usually develop first as a test. And then I go with other scenarios, with other possibilities. So I can say empty product name. And then of course, I write here, when I have a empty product name supplied as a name product that has been added, I want to have error reported and no products, and product is not added. So I proceed and I go from happy path to various edge cases. So like empty product or unauthorized attempt or database, for example, not available, etc., etc. So this is an example of what I do before I start coding. I cover these various scenarios. So this is scenario, and then I go and start with a happy path where everything is okay, and then I look for various edge cases that can happen to me or my code or my application. So this is the reason I have, instead of, okay, when we get back, so this is create product command. This is the reason I don't have single class here, but a folder. So I hope you can read the names. These names are reflecting various scenarios. So I have create product command, underline happy path. So this is my BDD test for a happy path execution of the create product command. And now you're looking at my test, and I will go over these to explain you what I'm having here. So I'm essentially using this duality. If you recall, let me see where TDD is. You have, with TDD, you have arrange, act, assert, preparing environment, seeding data, executing code, checking results of the execution. Now this is perfectly matching BDD. So instead of arrange, act, assert, you have given, when, then. So instead of arrange, you have given initial context. Instead of act, you have when event happens. And instead of assert, you have then expected outcome. And these are perfectly matching. They're perfectly matching with the, within their intention to set up conditions, set up environment for the execution, execution itself, or observing actions that are happening in dynamic system, and then finally checking if expected thing happened in the system, if expected outcome happened to you as a user of the system. So this is XUnit in action. So I'm not using any like specialized BDD framework. I'm concentrating to the essence. So the essence is not within the framework. The essence is within your approach of testing high-level business behavior and its outcomes. So in this case, I have a test. My given phase is empty. So I'm here testing adding of the first product in the empty system. So all of my setup, infrastructure setup, have been moved to this fixture, which I'm not going to open now. Just assume that whole infrastructure, which is provisioning test host for this ASP.NET application, has been done. Provisioning of in-memory database capabilities, everything is inside of the fixture. So I don't need, in this case, to prepare anything. So this is a bit degenerate case, but you will see it's completely understandable. And then I have when. And this code here, and I should have used region here to be able to more easily show you exact boundaries of the when phase. So I have something very simple here. I'm instantiating new HTTP request. So I'm preparing data structure for the HTTP request. Here I'm using test server to actually post to this endpoint. And what I will post is this value here. So I would dare to say rather simple. I'm testing controller, which exists here. So product controller has, and this is a bit, again, degenerate, but what I'm doing here, this is what I'm calling. I'm mapping command directly to the, I'm mapping HTTP request directly to my command. You can see how this command looks like. So I have command for these are input parameters for my command. I have name of the product I want to create, and I have a price. So I'm automatically mapping it and I'm calling it. So this is act phase. Here I'm simulating front end sending request post request to the API to create new product. So this is act phase. And now here I have testing or 3 DENs. So even if you go and check, if you check BDD terminology, you have something like this: given X, when Y, then X, and sorry, Z1 as the outcome, and Z2 and Z3. So in my example of creation of new product, this is empty because this is non-existent because system is completely fresh and empty. This is actual calling of the action of the controller. And then I have, after call to the controller executes, what I have are 3 outcomes of this call here. So I have 3 XUnit methods which are testing 3 outcomes of this post request to the endpoint product. So the first outcome is that call to this within these circumstances should return status 200. I will show you in a moment why I'm using this display name, but you can see that fluent assertions are making it very readable. So everyone can read that response status code should be 200. So this almost reads like a pure English. Then second outcome of the execution of call to this endpoint should be that one product now exists in the database, or that call to this created exactly no more nor less than one product in my database. So I'm here talking to RavenDB, which is running in memory at this point. I'm opening session, I'm querying products and pulling out statistics. And I'm checking if total results or total number of the documents in the database are 1. This is even stronger test than what it states here, because I'm not checking only number of the products. I'm fetching complete statistics, so I can even add some more conditions here. For example, I can use it to check total number of all entries in the database, which also should be 1. That way I can check if my code inadvertently maybe created some other objects like shopping cart, for example. And then as a third outcome, this one product that have been created has expected content. And this expected content should be precisely this one. So this is the reason I declared it this way, so that it can be accessible from my test. So you see, I'm fetching this single product. So RavenDB supports a link, as you can see. I'm fetching this single product in the database, and then I'm checking if name and the price of the product that was fetched from the database are actually matching what I sent to be created. And as you can see, these I also could join these 3 into one, but this would be a mistake because I would destroy business aspect of this BDD test. Let me show you something. When I switch to the test explorer, and don't be confused by seeing that some of my tests are failing, this simply means that I'm in the middle of implementation. So ones which are green are actually have been successfully verified as implemented, and the red ones are yet waiting to be implemented. And this is also interesting because on a couple of occasions, when I have new team members arriving, you don't need to tell them what to work on. You simply go and say, when you see test which is failing, pick it up and start working on the code to make this test pass. But I will now show you why I'm using this. So you remember I stated here scenario in plain English. And here you can see that, for example, create product happy path. So happy path of creation product means that status 200 will be returned. Let me expand this so you can see the full sentence. So in ideal case of creation of execution of the create product command or calling endpoint, I will have status 200 returned. One product will be created in the database, and this new product has expected content. So you see, this can be exported. This can be handed over to a business person to verify, okay, tell me, or I can email these. And business person will confirm if I missed any scenario. So for example, what happens, okay, this is happy path, it's clear, but what happens if I'm unauthorized and I'm trying to add new product, or what kind of permissions I need to have in order to be able to add product. And you also see here some edge cases. So for example, if I try to create product with invalid price, I should get back status 400 and no changes to the database should be performed. So let's look at this test. So you see here I'm testing with the invalid price, which means that my specification essentially reads price should be positive. So let's imagine I delivered, I got this bug report here, they can type minus price, and then I go and implement something like this before fixing the bug. So I write this test, this is failing, and then I proceed and correct my code. But you can also see here, this is the content. This will be the content of the HTTP request. It's used here, as you can see. Again, calling endpoint for creation of new product. And you see what I'm expecting here. So status in this case, with negative price, I'm expecting status 400 to be returned. And here I'm checking if no products have been created in my database. So I can be completely sure that this invalid call will not alter the content of my database. And to show you that it's working, I'm going to run Docker container to start RavenDB. Okay, so Raven is available through a web studio, which it is serving. So this is my RavenDB instance. I'm going to create new database called store. Okay, so I have empty database here, and I'm already running this with IIS Express. So if I switch here and go, so for testing endpoints, I'm using, I forgot the name of the extension for Visual Studio Code, but it's very handy. So what I can do is replicate call like this, URL, content type, payload, so I can send request for. Okay, and as you can see here, 200 OK have been returned, which means that I should be having content in my database. So if I switch here, this database was empty. What you can actually see here that one apple has been created. So you can see what I sent, apple and 19.99. This is precisely what has been stored in my database. Just to show you that it's actually working, I can go and use banana, and I can go with 935, for example. So when I again execute it, I'm getting 200 OK back, and here I have two products, as you can see, stored in a database. And of course, I could implement my tests in this same way, bring Docker container with the database running, run these tests again, Dockerized database, but here I have something better. I can run these tests where every single of these tests will receive access to its own in-memory version of a database, and it will actually work with this database. After test is done, my in-memory instance of RavenDB used for this test will be disposed. So what is now going on? It takes some time for everything to fire up. You see tests are executing, some of them are passing, some of them are failing. But what is very nice here, unfortunately, unlike, not unfortunately, so with, for example, Entity Framework, in-memory version is something completely different from actual production database. So your tests can be actually deceiving and harmful, because you will have, with Entity Framework in memory, you will have something passing, and then in production, this will fail. What is nice here is that every single of these tests got its own instance of RavenDB, which is binary identical to this one that I'm using here. And not only that, what is very interesting is this line here. You probably spotted it and ask yourself what this line represents. I will show you. So as you can see, these tests are failing. What I can do, I can debug them. And when I'm in the debug mode, as execution reaches this line, you will see what will happen when this line is executed. So let's go into debug mode. It's here. So if I go with debug, let's observe what will happen now. This will be now executed, call to this endpoint will be made, and this line will be reached. Okay. So this is now executing, and in a few moments you will see the magic. So what is happening right now is following. When this line is hit, execution will stop, and what will open in my browser? It's RavenDB Studio. You can see the name of the database here. So this is provisional database running in in-memory instance. And what this line resulted in is Studio being open in the browser, given me insight into this in-memory database. So instead of actually logging values, I can easily go here, open all the products in my database, and see what has been created. So I can visually verify that this test is failing, if you remember, because I should not be creating products with negative price. This happened, and here I can visually verify it, and in any other way, either observe or modify data or do anything I would like to do, but I can easily work with my data in my test database. If I'm done, when I'm done, I can click on this continue test button, and what will happen? Execution will continue from this line on, and you will see that this breakpoint will be hit. And also, what happened is that this temporary in-memory database will be destroyed. So I'm clicking on continue test. You see execution reached this line and stopped, and database is still, of course, here because this test needs to test it. But when this test completes in a few seconds, you will see that Raven Studio will detect, okay, I need to continue because I got exception. What you can see now is this is like a visual proof that this in-memory database does not exist anymore. So this enables me to run end-to-end tests and to mock as little components of my system as I can. For me personally, this is preferred way of working. I can show you another variant of this. project where I'm actually doing some mocking. So for the mocking aficionados, this is the way I'm mocking. So this is very similar project, but it's a bit more complex, so more features, more functionalities here. The part I want to show you is, let's say we are creating some kind of entries, and again, this is happy path. And what we want to check is that email is sent when new entry in the database is being created. So you can see in the same spirit of the test that I just showcased, I'm checking that status 200 is returned. So you can see, just to show you, I'm calling this entry endpoint, posting this, and I'm expecting one entry to be created with these three tags. So I'm checking if status 200 is returned, checking if one entry is created in the database, and this single entry that has been created has expected content. And then I'm checking if email has been sent with the proper content. How I'm doing that? I'm using Fake It Easy library for mocking interface. So as you can see, I have a very readable structure here, which is checking. So let me show you what this is. This is interface mailer with the method send mail. This method send mail represents essentially abstraction of the service for sending emails. It has address, subject, and the body. So Fake It Easy created proxy, and now I'm checking. This test here is checking if exactly one email has been sent, and I'm not actually checking if email has been physically sent. In this case, I'm checking if call to this mailer.send method occurred. I'm not interested in the content of the arguments. I'm just checking if this method was called precisely or exactly once. And then in subsequent tests, I'm checking if first argument was this. Of course, you shouldn't be hard coding addresses like this, but this is more readable for presentations like this one. So I'm checking if first argument of this method call was correct, second one, and the third one. This way, I'm checking if call to the method happened, and I'm not checking if this method had problems communicating with SendGrid or MailChimp. This can also be tested, but in this case, I'm showcasing you how to mock calls to procedures in this system of Gherkin. And also something very, very interesting here. Since RavenDB is exposing lots of statistics, I'm actually able to check how many sessions were opened by the code that was executed when I called this endpoint. So here, I'm checking that this endpoint up here, when called, will result in 3 sessions being opened to the database. So this is a bit more complex project. So I'm having authorization, I have authentication, I have logging. I have logging of all calls, all input data or output data. So I'm actually collecting within infrastructure for tests. I'm collecting data about sessions and their calls. And I'm essentially checking here that overall 3 sessions working with the database have been used. First one was call that was checking authentication and permissions inside of the database. Second session call was actually operation itself of creation new entry with the tags. And the third one was call to the same database to log data about HTTP request, etc. inside of the database. This is interesting because this type of test is something that I like to use not to check specific number of sessions, but to be aware what is going on. Because I can introduce something like select n+1 anti-pattern in my code, and then this test will fail. So tests like these ones are not outcome of the execution of the method itself. This is something that I'm using to be aware of how many sessions I'm opening towards the database. So it's not a problem if I refactor my code and this becomes 4 instead of 3. I will simply go inspect my code, say, okay, this change in requirement is now requiring 4 calls to the database. That's completely okay. But what I want to do is to be aware when something like this happens. So when my refactoring actually increases or decreases number of the sessions being open to the database. So this is more of something I'm using for awareness purposes. Since I have been talking a lot, do you have any comments, questions, suggestions, maybe how or problems you see with this approach? Okay, so overall, that is it. I just would like to show you if I can navigate through my own code. Bogus library. Let me see if I have. Yes, so this is interesting example. You can use bogus library to generate your test data. So instead of going with John Doe or Jane Smith or Laura Callahan, I can go and instruct bogus. Bogus has concept of a faker. So what you can see here, what I'm doing, I'm describing rules for populating these fields of the product. So product is my model, which I'm storing directly inside of the database. Since a RavenDB is a document database, RavenDB can store it directly. No ORM is needed. So here is set of instructions how to generate fake product. So as you can see, I'm using static mode, which means that all these fields must be populated. And as you can see, I'm generating GUID for the ID. Faker has set of pre-implemented methods which can generate product name, or as you can see in the commerce namespace, you can see I can generate random color name or name of the department, which is random, but it's coming from predefined set, so it will be natural for me to read it in as a human. Product name, materials, etc. So this is also nice to generate semi-randomized data, which sometimes can help you uncover some problems. And finally, the only thing that I actually did not show so far is the actual implementation. So here is the implementation that I showcase as working with this code. So as I said, I'm using CQRS, and this is command for creation of a new product. And this is something that some people do not like, placing several commands, several classes in one physical file. But this is, of course, matter of taste and conventions. So here is the class, which is, you could call it DTO for conveying arguments. Here is the handler that is used for this command. So I have two classes. I have command and handler. I register this handler as a handler that will process specifically this command, and I use dependency injection to perform automatic scanning of the assembly and registration. And then, as a part of this dependency injection registration, I can do something like this. I can say mediator send query or mediator send command. These controllers are anorexic. They are very, as you can see, very thin. What happens here is that actions of this controller are not aware who will handle these commands or these queries. We are populating, mapping automatically from the HTTP request this command. And then I'm handling it over to mediator. And task of mediator is to find handler which will process this command. So it's completely dynamically bound during execution time. And here is actual code. So I'm injecting document store, as you can see, in the constructor of the handler. Document store is the actual server. This is the abstraction of the server or cluster of machines. And here is actual part of the code, which is storing new product. So I'm opening session, async session. I'm creating new business domain object, which is product. And then and this part is very, very similar to Entity Framework. I have store and I have save changes. So session.store async of the product, and then session.save changes of everything that has been stored or changed that session was tracking. This line here will create asset transaction. Again, this is specific thing about RavenDB. RavenDB was first NoSQL database to offer asset transaction. From the very first day in 2010 when it was released up to today, asset transactions are must. So this line will create asset transaction. Only new things or changed things will be sent as a payload of this transaction. And because this is asset, if this line completes without any exceptions, you can be sure, as it is the case with any other reliable database, that your product in this case have been stored inside of a database. What has been collapsed here are additional examples of how I can validate command itself. So for example, this code will make this additional, you saw tests failing. So I just uncommented code which will make some of these tests pass, because what I'm doing here, I'm validating if product name is empty. I'm validating if price is lower than 0. If that happens, I'm throwing exceptions. Now, if you remember, my tests were checking for the status code 400 or 200 or some other status codes, and I'm throwing exceptions here. What I'm using behind the scene is one more interesting NuGet package by Christian Hellang, which is called problem details. And this one is mapping exceptions to the return codes. So you see, when I'm throwing validation exception, this middleware here from the startup CS will map this exception to the status code. So actually, when you look at my code, this code is not aware that it will be maybe called from the controller. Because what you don't want to do, you don't want to unnecessary couple things. You want to write clean code. So this clone code is cleanly throwing exceptions. And then since this code is executing within ASP.NET controller, what I have as a part of the infrastructure is mapping of these exceptions into status code. So you see, this will, when I'm throwing validation exception, this will return status code 400. So let's see if this will work. This is invalid price. Let's see if my newly uncommented or newly added code will make this pass. So this will again instantiate in memory test host, web server running in memory, database running in memory. So let's see if I manage to fix this. Okay, I hope this will soon show its results, either good or bad, but conclude execution. Okay, so you saw me correcting my code to make these tests pass, and now I know that I fixed this. In the same manner, so I was here validating input parameters, which are essentially this command. I collapsed, so this command. And I can also add some more validations for some more tests to pass. So what happens if I already have a product with the same name in the database? This is one more scenario. It's somewhere here. It doesn't matter. but this is one more of these scenarios where I want to cover the case if I'm trying to override existing products. So here I'm using session that was opened here. So I'm saying session.query products, give me product with the name that's equal to the name of the product I want to create now. And if it exists, again, I'm throwing validation exception, because this is, now you see combination of two types of validation. I have business rules and I have input parameters validation. So this is validation of input parameters or request parameters and request values. And here I'm checking business rules. So actually this business rules rule will appear as one of the tests here. When you attempt to override existing product, status 400 should be returned. So I'm throwing exception here if this is the case, and this exception will be mapped by Christian Helling's problem details component into stated that is returned. So you see, I'm also using middleware to a lower amount of the cross-cutting concern covering code. Because sometimes you will recall that sometimes you have more of these cross-cutting concern like logging and validation than the actual code itself. Okay, I think I reached the end. I hope there's a total silence. I hope this is a good sign. This is existing on my GitHub repo as a open repository. So go ahead, please, and try it. And any kind of criticism is a good thing, because I will improve my skills and see things from a new angle.
Okay, well, thank you very much, Dejan. That was wonderful. Does anyone have any comments or questions?
Yeah, in the very beginning, this isn't even related to the talk, but you said something about an issue you were having with Visual Studio, where when you click the CSproj file, it would automatically open.
Yes, so I'm complaining about the fact when I want to select a project, for example, instead of clicking and saying, okay, this will be default project to run, when I click on it to select it like this, it opens a CSproj file for editing. So I'm just slightly annoyed by it. I never took any Googling effort to turn this off, but I will just mention, if anyone knows, please email me with the solution.
I don't know for sure, but stuff like that would probably be in tools under projects and solutions, tools, objects, projects, and solutions. I don't know for sure, though.
Okay, I will check it. Thank you. Just one thing, we have a couple of more minutes. I can show you just brief tour of RavenDB. And I don't know if you have experience with NoSQL database, but I just created empty database. I'm going to seed some sample data. This is actually Northwind database being remodeled. And as you can recall, this is running in my Docker container. So essentially, with NoSQL databases, you have ability to take a business domain object as it is and just give it to the database. It will be serialized into JSON like this one and store directly. Later on, you can fetch it. And this means that if you're doing, for example, domain-driven design, and when you start using NoSQL databases, or precisely speaking, document NoSQL databases, you will conclude that they are perfect match, because now here I have my purchase order being modeled as a JSON document. I started with a piece of paper which represents purchase order, and I modeled it here. And I'm not forced anymore to split this into several tables And main reason you split into several tables is because tables cannot hold collection like these or the lines. I'm not forced anymore to use it, so I'm able to model it this way. And if you recall domain-driven design, what you're looking at here is actually document that has very nice transaction boundary, meaning that if you, for example, delete this order line, there will be some propagating changes. So freight will be changed, total amount of the order will be changed, maybe even shipping address might change depending on the content. So all these propagating, rippling effect changes will be contained within this document because it represents transaction boundary. So if you're doing domain-driven design, go ahead and try out one of these NoSQL document databases, because they are actually much better fit for use cases like those ones compared to relational database. NoSQL databases are rather mature technology, although most of managers that are skeptical will claim that this is new technology. But when I speak to developers, I can see developers like myself are thrilled to use something like this. So no more need for ORM and no more need to do any kind of persistence layer model. So you essentially erase complete layer from your application, less coding, and these databases are also very performant. Okay, that was it. You can see my email here. If you have any questions, remarks, suggestions, I would be very glad to hear it, because as I usually say, when people tap you on the shoulder, it's pleasant, but it's not useful. I would prefer comments which are not pleasant but are useful to improve my presentation skills and my programming skills. Thank you for your attention. Of course, if you have any questions, we have a minute or two more.
Well, thank you very much for staying awake so long.
You're welcome. It was interesting. I'm very passionate. Still, I'm not a junior developer, but I'm still very passionate about my profession and coding. So it was a real pleasure. And thank you one more time for having me.